Yeah, so hello everyone, and today we'll be seeing one of the problem from Leetcode. It says maximize happiness of selected children. What a noble question. Well, what does it mean? You are given an array happiness of length n and positive integer k. There are n children standing in the queue where ith children has happiness value of happiness of I, which is pretty standard, okay? You want to select k childrens from these n childrens in k turns. Nice. So you wanted to select only k childrens. Nice. In each turn, when you select a child, the happiness value of all the children that have not been selected till now decreases by 1. Note that the happiness value cannot become negative and gets decremented only if it is positive. Return the maximum sum of happiness value of selected children you can achieve by selecting k children. Very interesting. So we have a few examples over here where happiness is 1 to 3 and we have to select two children, so it makes sense to take 3 first and then go ahead with 2, but it's a second child which we are picking, so it would decrement its value. So 2 is no longer 2 but it's 1, so 3 plus 1 is 4, and that's why we got it over here. Fair enough. Similarly like this, so 1 for any two children, because anytime we pick any one of the children, rest all would become 0, so there's no point. And with only one children, 5 is the utmost. So it's a classic problem of greedy solution, so where you go ahead and when you pick up the maximum element, so here we take the maximum element, so I'll take consider the max elements, and there is one other catch where you have mentioned that rest all decrements by 1. So how can you handle this? Can you go ahead and decrement every element by 1, or you can just take a track that hey, this is my ith element, and then I will reduce the value by I. So if it is a 0th element, you would reduce the value by 0 minus 0. If it is one element, you would reduce by 1, 2 element minus 2, and so on. You got the drill, and ultimately you just go ahead and return the score. Fair enough. That's a very good one. So how can we solve this problem then? So first of all, we have to consider the maximum elements, right? So what we do here is we can just, let me full screen this. Yeah, we can just go ahead and sort the array, and with that, what will let me first, okay, we can just go ahead and sort the array A, and that will give us a very decent way to iterate from maximum and minimum. And I wanted to iterate from 0 to k elements. I wanted to only pick k elements, right? And I wanted to pick the last element as we want max, right? And there would be a long score which initially would be 0, and that would be the item we would be returning, score. Fair enough. Now I would take the current score, or int current score is equal to a of n. What n is a final int, n is equal to a dot length minus I minus 1. So this would give us the last element. So if I is 0, it would give n minus 1. If I is 2, I is 1, then it would give n minus 2. So I am iterating from back, minus the turn, which means I. So you remember, if it is 0th turn, I would minus 0. If it is ith turn, I would minus I. So I got a current score. If current score is lesser than or equal to 0, I don't want it to continue any further. Break it right from here. And then if it is not, then I'll just add it within the score, current score. Cool. Let's compile this code. And it is accepted. You see, there's a branching. I don't want the branching within my code. So it's a pretty simple code. So let's remove the branching first. And let me introduce mat.max. Either 0 or current score. Let me submit this now. This is a concept known as branchless coding, where you don't branch a solution, or where you just have minimal if conditions within your code so that you avoid branching within your code. And that leads to very good solution when you deal with the production grade systems. That is all about it. It was a very fair problem dealing with the greedy algorithms. The time complexity for this algorithm is n log n, as we involve sorting, and as we are not using any extra space, so space complexity is a constant. For more such greedy algorithms, click the video on your right, and I'll see you in the next one.